You are trying on your perfect outfit for this dance you're looking forward to going to. And you start off by doing your skincare, and then you put on your outfit, and then you do your makeup, and then you put on your shoes. When you get back home from the dance, you undo the process in the opposite order, right? So instead of doing your face care or your skincare first, you're going to take off your shoes first, which was the first thing that which was the last thing that you put on. Then you will remove your jewelry, you will remove your outfit, and then you will do your skincare. And actually, it shows in this picture. I use ChatGPT to, create these images so they're not 100% perfect because it shows that she has her outfit on and then puts on her skincare, or does her skincare and removes her makeup. But you get the point. Basically, you're just undoing the process, right? Um, so this is exactly what's going on in inverse functions. And when we talk about inverses, we are looking at, again, undoing. And so a few other examples of this. Oh my gosh, my PC may be at risk. That's not good. um, a few other examples of this is the inverse of an exponent is a log. The inverse of multiplying is dividing, and the inverse of adding is subtracting. And of course, there's more examples of this as well, but just wanted to give a general idea of some other examples. And it's not the opposite, it's just undoing, right? So I want to make sure that that is understood. Okay, so if we look at it from a function standpoint, we can see here, let me grab a highlighter. Ooh, there we go. On the f function, we can see that 1 maps to a, right? And then for the inverse, which is denoted by this -1, a will map to 1. So it's the undoing of the function of f, right? You have 2 that matches to b, and you have b that matches to 2 in the inverse. Notice how f maps 1 to a, and the inverse of f undoes this. That is, inverse of f maps a back to 1. And a really important thing to note here, so I'm going to grab a different color highlighter, is to not confuse the inverse of x with the exponentiation, because the inverse of f is different from 1 over f of x. So even though it looks the same, it's just, how you denote it in mathematics. Okay, so now looking at it from a graph form, let me zoom out here. If we're looking at it from a graph, all that the inverse is, if I have this line y equals x right here. If you can hear my cat in the background, I apologize. She's been meowing all morning. Kitten behavior, So y equals x is a dotted line that is represented on this graph here. And the function f is here, and the inverse of f is there. And all that the inverse is a reflection across y equals x. So all that's happening is that you're switching the x and the y coordinates. So if there's a point on this function f that's -2, -3, let's just say that's right here. On the inverse, it would be x is -3 and y is -2. So it's really just the switching of the x and y coordinates, right? Okay, so again, reflection across the line y equals x, and it's the switching of the x and y coordinates. Okay, so now let's look at algebraically how we can solve these inverse problems. All right, so I have steps 1, 2, and 3 here. And we're going to start off with a pretty simple one. So the first step is we're going to replace f of x with y. Why do we do that? Because f of x is essentially the same thing as y, and it just makes it look a lot cleaner and not as confusing. And eventually we're going to swap the x and the y and then solve for y, and just having something in the equation without parentheses just is helpful. So we're going to start off number one, y equals 3x plus 5. Okay, first step is done. Next, we're going to swap the x and the y. Why are we doing this? Because, like we said before, in order to find the inverse, we are switching the x and the y coordinates, and we are solving for y. So I'm going to take this x value right here, and this y value, and all we're going to do, if I can get my pen to work properly, is swap them, right? Okay, so now we have x equals 3y plus 5. Now, to solve for y, right now we have x by itself, but we need to get y by itself, right? So we will subtract 5 from each side. And this will give us x minus 5 equals 3y. And the final step is we divide both sides by 3, and we are left with y equals x minus 5 all over 3. And this is the inverse of function f. So actually, I skipped a step. We have to write this with the inverse notation, which is f negative 1 of x equals x minus 5 all over 3. So let me just to be clear, I'm going to erase this and make sure to, oh my gosh, my cat is being super loud. I do not know what she wants. She already ate and I already played with her. So anyways, yeah, so we just swapped this f of x back into the original equation and then use the inverse, right? Okay, perfect. So moving on, we have, I think, 2 more problems. So this is the second problem, and then we have one more that we're going to work with today. This one's a little bit more complex because we have a square root right here, right? So we have f of x is the square root of x plus 4. All right, but same steps that we have here. So f of x, we are swapping, or we're replacing it with y. So y equals the square root of x plus 4. And we are swapping x and y. So x equals the square root of y plus 4. And if you can remember what we need to do to solve for y, we have a square root on the right side. And what undoes a square root? Well, we can take the exponent on both sides. So if we square this square root and square the left side, our x on the left becomes x squared equals y plus 4. And now to get y by itself, we just subtract 4 from both sides, right? So we get x squared minus 4 equals y. And last step, we just remember at the beginning we swapped y for f of x. Now we have to swap that back and have it written as the inverse. So our final answer will be the inverse, the inverse of x equals x squared minus 4. It does not look like a 4. There we go. And that is our answer. Amazing. And let's do the final problem together. All right, we have f of x equals, in parentheses, x minus a cubed all over b minus c. Let's not freak out. I know we got a fraction in here. We have multiple variables, but let's just focus again. We're solving for y, right? So these a, b, and c's, you can just think of them as regular numbers, constant numbers. And we are going to be following the same process. So let's get started. We are replacing f of x with y. So this becomes y equals, everything else stays the same for right now, x minus a cubed all over b minus c. All right, now we're swapping x and y. So this becomes x equals y minus a cubed all over b minus c. And again, we are solving for y, So this right here, so don't worry about the a, b, and c. We just want to get y by itself, right? So let's see. The first thing I'm going to do is I'm going to add c to both sides. So if I add c to both sides, let me just make sure. So there's multiple steps in this one, so I want to make sure everyone's following along. Adding c to both sides. And we will get x plus c equals y minus a cubed all over b. Now I'm going to multiply. To undo this fraction, I'm going to multiply b by both sides. So then the b's will cancel out, right? So that makes the b's cancel out, and I am left with b times, I'll leave a dot there just so we're very clear, x plus c equals y minus a cubed, right? Okay, so we now have the fraction is completely gone. So we're dealing with a linear equation. Actually, it's not because of the exponent. So we got to get rid of this cube exponent here. And in order to do that, we are going to take the cubed root on both sides. Just how in the previous problem, we squared the cubed root, or the square root, in order to get rid of the root. Now we have to take the root in order to get rid of the exponent. All right, does that make sense? So we're going to take the square, or the cube root of both sides, and that would mean that on the right side, this pen is so sensitive, the cubed root and the exponent are going to cancel, and on the left side we will have the cubed root of b times x plus c, and all of that equal to y minus a. And the last thing that we're going to do here is just add a to both sides, right? Because we got to get y by itself. And make sure when you add this to both sides that you are x plus c, you are making sure that the a that you're adding is not inside of the root, right? And we're going to set that equal to y. And the last thing, remember, because we swapped the f of x for y at the beginning, we will just swap it back, but make sure that it's the inverse. So we have the inverse of f. Oh, I did that last time too. Inverse of f of x equals cubed root of b times, you can put this dot here or not, it's up to you. I'm going to leave it here just so it's very clear. X plus c, we'll expand that root and then make sure that the a is outside of the root. And this is our final answer. All right, so that was all of the problems that I had for you today. So thank you so much for joining me, and I will see you back in the next video. Thank you.